right. Good afternoon, everyone. My name is Angie. Sorry, running a little bit late because I forgot the password. And Twitch just wanted to make sure that everything is good. So we're here. We're ready. Welcome to After School STEM at the Headwaters Science Center. Today we're going to be talking about models, and I'm alone and safe, so I'm going to take off my mask just because it's a little bit easier to speak. All right, so we're going to talk about models, and models are a really useful tool in a lot of different disciplines, but specifically in science. And there's a few different types of models. So the ones that I have in front of me are what we call visual models, and usually those are used to help us imagine or understand things that can be a little bit difficult. And these kinds of models are really, really great for looking at things that are really, really way too big or very, very small. So the first model I'm going to show you is this really cool machine here. This is called an orrery, O-R-R-E-R-Y, something like that. And this is a model of the solar system. Now, obviously the solar system is way too big for us to really see with our own eyes. And so something like this can help us think about the relationships and things like that. So specifically, this guy, what it does is it spins, and as it moves, the different planets and moons and things sort of rotate, and so we can get an idea of the motions in our solar system that are hard to see. So this is a good example of a model being used to visualize or think about something that is really, really big. So I'm going to get this out of the way. The next big thing, this is a model that we actually used earlier this week, and this is a model of a watershed. Now, a watershed is much smaller than the solar system, but it is still a really, really big area to imagine. And so what we can do with this model is we can add things to it to act like different, so we can add dirt and powders and chemicals, and when we sprinkle water on top, the water will flow in a manner that sort of mimics the natural watershed. Right. So we use models all the time in science, and so we just looked at a couple models showing things that are really, really big. But another place that models are really handy are for thinking about and explaining things that are really, really small. So this here is a model of an animal cell. Now, animal cells are very tiny, and I can't get the lid off, but you can see all the different parts of the cells. So we've got our nucleus and all that fun stuff. I'm not going to go through all the little pieces and parts because it's been a long time since I've had a biology class, and I'll probably get it wrong. All right, so here is a model of a human or an animal cell, I guess. And we go even smaller than that. These are models of a water molecule. So we've got oxygen as a red circle and hydrogen as the two little white parts. These little models are actually magnetic, and so not only do they help us visualize what the molecules look like, they can also help us visualize the way the molecules might act. So water is a really interesting substance. It's everywhere, and it's really strange. So when water is liquid, it tends to form rings and chains, and so like this could sort of represent a small drop of water. All right, when water freezes, it gets really organized, and all of the molecules kind of line up. And if we look, let's see, if you look, you can see there's spaces in between, and that is actually, those spaces lead to solid water, ice, being less dense than liquid water, and so that's why ice floats. But that can be really hard to visualize in our heads, to just imagine. And so we can use things like this to help us learn about it, to help us understand it. Some of us are what we call visual learners. So I could describe a molecule all day for hours and hours and hours, and it still probably wouldn't make sense, at least in my head. But if you show me a picture or show me a model, I'm going to understand it much, much more easily and probably more quickly. All right, so these are a few examples of using models to think about and understand concepts that are really, really big, like the solar system or an entire watershed, and also looking at things that are really, really small and kind of hard to think. But another really cool thing about models is when we have things like fossils. Fossils are very delicate and they're very, very rare. So this is, let's see, which one is this? So this is Australopithecus. All right, and so in this model, you can see there's two different parts, right? There's kind of this smooth, lighter color, and there's this rough, darker stuff. And on this model, it kind of represents, so this darker stuff are the actual pieces of fossil that scientists found, and this lighter stuff represents parts that scientists have sort of recreated to kind of give us the entire picture. Now, the actual fossils that were found are very delicate. There's, not very many. And so we wouldn't be able to just pass them around and let everybody have a peek. They certainly wouldn't let us keep this fossil on a table at the Science Center in Bemidji. This is kept under lock and key. So by using a model, we can make an exact replica that is both sturdy and cheap. And so we can pass this around and people can get a look at it, kind of compare it to feel like what it looks like to our own heads. So models can make an opportunity for things that are very rare or very difficult to find or very delicate. They can give us the ability to look at them, handle them, manipulate them, things like that. Okay. They're also really nice for, obviously, for educational purposes. So we've probably all seen a fish, but the chances of us being able to see the insides of a fish is much more difficult, and it's kind of messy. If you're not into that sort of thing, it's could be kind of gross, maybe especially if you don't eat meat, you don't want to touch this kind of stuff. You can sort of learn and explore. We can find out what the inside of an animal or a plant or anything really. We can sort of look at it and explore it without getting our hands dirty, and the organism that is dissected has to die. So we could use this over and over and over again and save a little money. Right, so these are here's another example. Now this is a pair of lungs, and I've actually seen this model at a doctor's office that I went to. And so here's a model of different diseases that can affect a lung, a human lung. So here we've got all the growths and tumors and scar tissue and things like that. When, if a doctor were to describe, it'll turn your lung black and icky, that might not have the same effect as showing you a gross blackened lung or a lung with a tumor on it. It can be a more effective tool for looking at things. Also, it's going to be really hard to find a pair of human lungs, and they're made out of flesh, and so they're not going to last very long. Eventually, just like any old piece of meat, they're going to get yucky, they're going to start to rot and decay. Whereas this is plastic, it'll last, basically forever. So that's another good reason to have a model, is they're reusable. So here, this is a groovy little, this is also lungs, but these lungs are going to show us the different blood vessels. Let's see if we can get them on there. There we go. So here, not only can we see the different vessels, but they've been color-coded to sort of help us differentiate between the different kinds. And that's something that you couldn't do even if you had an unlimited supply of, let's say, real stuff. All right, so speaking of real stuff, This is also a model. This is a life-size model of a skeleton. So all of these pieces are made out of plastic and metal, but they are modeled after real human bones. And so it gives us a chance, you know, if we were a medical student or perhaps just a biologist, you know, we could explore how the different bones move, how they interact with each other. And these kind of models have varying degrees of how fancy they are. This one's kind of a middle of the road. It's fairly plain. Some skeletons will have attachment points for ligaments and things like that. These are not by any means cheap, but this is much more affordable than a real human skeleton. And again, it's more durable, it lasts longer, you know, there's no ethics between, you know, a big plastic skeleton versus a skeleton from an actual human that may or may not have a questionable source and things like that. And so, you know, that just removes a whole genre of questions. And this is just a teeny tiny model of a skeleton that I actually found it in the garbage, and that's how much of a weirdo I am. Okay, so we've got all of these really cool visual models that we can use to help us visualize and think about, but these are actually not the most important kind of models. So the best kind, or perhaps the most useful kind of models, are mathematical models and computer models. So we can use mathematical models. One of the most simple basic ones that probably most of us have learned at some point is F equals m times a, or force equals mass times acceleration. So if we know two of those numbers, if we know force and mass, or mass and acceleration, we can figure out the other numbers using a little bit of algebra. Another really common sort of easy one is to figure out stream flow. So if you find out how wide and how deep your river is, you can measure how fast it's flowing, and you can use math to make a model of how much water is flowing through that river or stream at any given moment without actually having to measure how much water is like pouring into a giant cup, right? So those are a couple of really simple mathematical models that we use, you know, maybe not every day, but we can use it whenever we want. Mathematical models can get very, very complicated. A very complicated and very useful mathematical model is used to predict the weather. So weather forecasting has tons and tons and tons of modeling. There's math and computers and historical modeling. All of those things come together, and I think meteorology is probably one of the best examples of modeling in everyday use. And we can also use modeling in computers especially for things like building. So if we build a building and we want to think about or understand how it's going to act in high winds or you know, during an earthquake, we can use computers and math to run models, and we can see, you know, yep, this building is definitely going to survive, or, oh, you know, if it gets to be a certain kind of windy, we're going to have to, you know, reevaluate. So that is my very quick discussion about models and using models. If there's any questions, I would love to answer them for you. As a side note, if you think to yourself, man, I really love playing with toys, might I suggest a career in science education? Because I don't know about you, but as far as I'm concerned, these are all just really cool toys, and I get to play with them whenever I want. All right, that was After School Science. Remember, we are open, so you can visit the Science Center on Fridays, Saturdays, Sundays, and Mondays. Friday, Saturday, Monday, we are open from 9:30 to 5:30, and Sundays we are open from 1 to 5:30. So if you enjoyed this, we are on YouTube, we are on Facebook, and we are on Twitch. If you follow us on one, go check us out on the other. We're trying to get more followers and subscribers on our Twitch and our YouTube. And when we get more people following us and hanging out with us, we just unlock cool stuff. So please check that out. All right, everyone. See you later.